Okay, so let's continue on the last type of the amplifier that will be covered in the syllabus. That is summing amplifier. So from the name of the word summing, so what does that mean by summing? So we have a few more than one input connected at the negative. So this is inverting or non-inverting. See, the input, this is all the sine wave, V1, V2 and V3. So this is generated from inverting amplifier. So at your inverting amplifier, there are three inputs, V1, V2 and V3. And all of them are connected to their own resistor, R1, R2 and R3. And the feedback will be maintained at the negative, and there will be one feedback resistor here called RF. So this point here denoted by virtual ground. So why we call this summing? Because we have multiple input. Okay, now so let's try to derive again the gain of the summing amplifier. So what will be the gain of the summing amplifier? First, voltage rule. So this is R3. Voltage rule is saying here is connected to the ground. So here is 0 volt, and your virtual ground here is also 0. So by applying KCL, so this is I1 plus current entering the node of the virtual ground, I2 plus I3 equal to I4. And by using golden rule number 2, there will be no current flowing inside the op-amp. Okay, so what is the I1? So I1 is the voltage drop across the R1, so means V1 over R1 plus V2 over R2 plus V3 over R3 equal to I4. So what is I4? I4 is 0 minus V out over RF. So how are you going to find the V out here? So V out equal to, just rearrange this one, minus RF V1 over R1 plus V2 over R2 plus V3 over R3. So this is how you're going to get the output voltage for the summing amplifier. You don't need to derive the gain because you have multiple input, right? So you just stop here. Okay, so let's do one example here. The question say the word here design. Design the summing amplifier to produce a specific output voltage. So this will be the output voltage. This will be the input voltage. So there will be only two input here. So we don't have this one. Okay. And you're given RF here. The feedback resistor here is 10K. You know your V1 is minus 1 volt. Your V2 here is 0.5 cos omega t. Okay. When the question said design, means what does the question want? You need to find the value of what? Value of resistor. So again, when the question says design, means you need to find the value of the resistor. So this is important. Okay. So let's go back how you're going to derive this one. So just now you already derived V out equal minus RF V1 over R1. So in this question, we only have two inputs. So we stop until R2. So it's given V out is equal to 1.25 minus 2.5 cos omega t. Your RF is minus 10K. Your V1 is minus 1 over R1 plus your V2 is 0.5 cos omega t over R2. Okay, so you do the right one first, so it becomes 10K over R1 minus 0.5 cos omega t over R2. So 1.25 minus 2.5 cos sine omega t. So what you will do now, you're going to compare. So this is without the cosine, right? So this one you're going to compare with this one. So what does that mean? So 1.25 equal to 10K over R1. And then you can get your R1. So for the other one, where you're going to compare between 2.5 cos omega t with 0.5 cos omega t divided by R2. So let's try to solve here. So this become 2.5. Cosine and cosine you can cancel. So it becomes 0.5 divided by R2. And then you can get your R2. So here you can get your R for just now, this is 10K, and then you take note here, it's also multiplied by 10K, and then you can get your R2 is 2 kilo ohm, your R1 is 8 kilo ohm. So the equation is solved.